I'm going to show you how to solve this differential equation by separating the variables. So before I separate the variables, I can see common factors in the numerator, which I can factorize, and I can also see common factor in the denominator. So let me do the factorizing first. So EX is common in the numerator, and Y is common in the denominator. So now I'm going to separate the variables. I'm going to take all the Y terms and put them on the left. So I have y squared plus 1 over y, and when I bring it to the left, it becomes y over y squared plus 1. And on the right, I have all the x terms, so I have ex remaining and ex plus 1 remaining, and dx moves. So I will just have to integrate both sides. So to integrate the left hand side, I'm going to use substitution. I'm going to let u be equals to y squared. So du dy is 2y. So I can see y here that will match with this y, but I will remove this 2. So bring the 2 over, becomes half. And I'm going to let du be here and move dy up. So half du equals to y dy. I can see y dy here, which will give me half du. And I have a y squared plus 1, and y squared is u, so this is u plus 1. So on the right hand side, I'm also going to use integration by substitution. So I'm not going to use u, I'm going to use w, so as not to confuse with the u here. So let w equals to ex. So dw dx gives me ex. So dw equals to ex dx, and I can see ex dx here, which is what I want, ex dx. I can replace with dw. So ex dx can replace with dw. And here I have ex plus 1, and ex is w, so I have w plus 1. So now I can perform the integration. I can see a half, which is a factor. So I just have to integrate 1 over u plus 1, which gives me ln u plus 1. Integrate 1 over w plus 1 is ln w plus 1. So let me now subtract the u as well as the w. U is y squared. W is ex. So I have a half here, I'm going to multiply across. Here I can apply a logarithm result. There's a logarithm rule that tells me that if I see a ln b, a factor in front of a logarithm, I can actually rewrite this as a power of b. So this a can be brought out as a power. So this 2 can be brought out as a power. So to remove this ln is to rewrite as exponential on the right. So removing the ln gives me exponential on the right. So I will split this up by using a to the power of m plus n to be a product. A to the power of m plus n can be written as product. So on this side, I have y squared plus 1. I'm going to bring the plus 1 over already. So finally, I can see e and ln coming together, which will offset each other and cancel out. So I'll be left with ex plus 1 square. And I have exponential of a constant, which gives me another constant. So let's just call this another constant, let's say a. And then I have a minus 1. So this is my general solution.